All right, thank you, Willem, and good morning from lovely Da Nang, Vietnam, where I'm privileged to be this week. So I am Shumon Huque, and I'm going to talk about automation of DNSSEC. So this presentation is joint work with Steve Crocker, who I'm sure many of you know. And he and I have been running a panel on this topic for a number of years at ICANN's DNSSEC and Security workshops. And in the appendix of my slide deck, which should be online, you'll find links to the material from those panels, which go into the subject matter in considerably more detail than you'll hear from me in the span of the next 20 minutes. So our main goal is to fully automate DNSSEC provisioning and maintenance to the extent possible. So this includes initial provisioning and bootstrapping of delegation signer or DS records, and also ongoing maintenance, such as updating of DS records as key rollovers and things of that nature happen. A related area of concern is how to automate the deployment and configuration of what are called multi-signer deployments. And this is where two or more distinct providers serve the same zone but sign data independently with their own keys. And it turns out such a configuration can also be used to seamlessly transfer a signed zone from one provider to another provider, and we need better tooling and automation there too. And a key proposition of ours is that robust automation in these areas should make it easier to deploy and manage DNSSEC. Maybe that will increase adoption, and it will certainly, we hope, reduce operational errors, which are unfortunately still seen in the field from time to time. So as I suspect most people, at least in the OARC audience knows, DS stands for delegation signer, and this is a signed record that is located in the parent zone that indicates that a child zone is in fact signed, and also identifies the DNSSEC public key, which is authentic and to be trusted to authenticate data in the child zone. So when a zone is newly signed, or when it's already signed, but it's changing its keys, the DS record in the parent needs to be created or updated. And what we want to do is automate this interaction so that it can happen transparently and without friction and without needing any manual steps. The first case to consider is where the registrar is also the DNS operator. And here, the ability to automate DS updates is actually fairly straightforward, at least in principle. So they are performing initial signing of the zone and also key rollovers when needed. So they know exactly when the DS record set in the parent needs to be updated. And also, crucially, they have at their disposal the mechanisms to authenticated channels to the registry that enables them to make those updates. Similarly, when the registrant or the zone owner operates the zone themselves, they also can automate DS updates fairly easily because, again, here they have direct access to the authenticated registrar APIs that provide those functions. A more challenging case is where the zone is hosted by a third-party DNS operator because, unlike the two previous cases, they don't have direct access to the registration system. So mechanisms exist to enable this use case to work. The main method is the use of so-called CDS and CDNS key records. These are published in the child zone, and they identify the new keys, and they can also be used as a signal to the parent zone that the DS record set needs to be updated. So the question then is, how does the parent detect the presence of these records? The dominant method today is simply by polling the child zone. So that means doing this comprehensively at a registry means that they need to periodically scan the entirety of their zone, find all the delegations, and query each of the child zones. So this technique, as you might imagine, is rather time-consuming and laborious, and it has plenty of critics and detractors, even in our own community. So if you were here yesterday at IDS, yes, I see someone raising their hands, you probably saw an animated Johan Stenson declare how much he hates scanning, right? So, but many folks have suggested that this technique won't scale well, particularly to extremely large registries or as DNSSEC deployment, which is still very sparse underneath the TLDs as it truly ramps up in the future. So certainly we can debate that subject, whether it works or not, but purely from a technical perspective, it's obvious that an explicit notification system would be far superior to scanning. So there are techniques being proposed or under development for this. For example, some DNS operators that primarily use REST HTTP-based configuration management schemes, they're looking at things like dynamic webhooks, and other folks are looking at mechanisms native to the DNS protocol to do this. So you heard yesterday again from the same talk about extending the use of the DNS notify message. That's generalized notify to have it do other things. So notify today is used almost exclusively in relation to zone transfer operations. So the proposal is to extend the use of the notify to do other things like notify a third party that a DNS key has changed. All right, so when enabling DNSSEC on a zone for the first time, we have an additional bootstrapping challenge because there is no pre-established secure chain of trust down to the child zone. So even if the child were to publish CDS or CDNS key records, there is no way to cryptographically verify their authenticity. So if you read the spec, you'll see that it does permit weak forms of validation. So you could do things like trust on first use or accept after delay. I think some folks go further and they use what are called multi-vantage point systems to confirm that the responses are the same when queried from many locations. But in reality, all of these techniques are vulnerable to active attackers, right? So what we really would like to have is strongly authenticated bootstrapping. And there is a proposal making its way through the IETF at the current time on authenticated bootstrapping, which offers one such method. There's a link to the draft in the slide here, which you can read the details at. So this works when the DNS operator manages the name server names in a assigned zone that they themselves operate. But it's not a complete solution, but there are many other situations where it won't work. For example, if you have in-domain servers. Okay, so this diagram shows the possible ways a third-party DNS operator could, in theory, convey DS updates up to the parent registry via two categories of methods, pull or push-based. So the pull methods are shown in red, and the push in the blue. The current existing technique that people have actually deployed is the red solid arrow shown to the right, where the registry pulls CDS, CDNS key records from the registrant zones directly. And some CCTLDs are in fact successfully using this technique today. The dotted red arrow, I'm going to talk about a little bit later, that is something that is slowly becoming a reality. On the other hand, the blue arrow is going in the other direction. The push methods, those essentially don't exist today. So mechanisms could, in theory, be devised for this, but they probably will immediately run into contractual and business impediments. So those things needed to be sorted out first. I'm not saying this won't work. It seems infeasible today. It could work in the future, but it would need quite a bit of work. All right, and so now I'll expand on the red dotted line in the previous diagram. So this is where the registrar, rather than the registry, scans CDS, CDNS key records in domains that they manage, but which are hosted at third-party DNS operators. And then they use the authenticated means at their disposal to communicate with the registry and automatically update the DS records. GoDaddy has kind of been leading the charge in this area for a while. I've linked a presentation that they've done in a previous ICANN meeting. They have a pilot program in effect today that does this, but it is not rolled out into full production to my latest understanding. But in the meantime, I came across recently another registrar that is, claims to already be doing this. So domain name shop, you can see what they do, but essentially this is scanning and automatic updates. Okay, so another interesting question is, what about the generic top-level domains that are contracted parties with ICANN? There hasn't been much movement in this area to date, and part of the issue has been a lack of understanding or clarity about what they are permitted to do. is, for example, a gTLD registry allowed to scan CDS records in registrant zones directly and update DS records? Or are they not allowed to do that? Or are they allowed, but they have to go through some formal policy approval process? So I don't know if Jim Galvin is still here. He was here earlier this week, but he did an excellent presentation a few years ago at ICANN that highlighted some of the impediments involved if we wanted to solve this problem. Francisco Arias from ICANN has also talked about it recently, earlier this year. But essentially, this is an area of interest. So some gTLD operators like Tango Registry, the link at the bottom, they are actually actively looking at doing this kind of scanning, despite being a contracted party gTLD. Next, I wanted to give a quick overview of the current state of DS adoption across the ccTLDs, right, where there's contractual rules don't impose an impediment. And we can do this by looking at the DNSSEC deployment maps that are now hosted at GMU, at the URL at the top of the slide you see. So the first picture shows the general deployment, and you'll see here that 43% of the ccTLDs report that they have operational DNSSEC. So operational DNSSEC means that they're signed, they have a DS record in the root zone, and furthermore, they accept DS records from child zones. And this shows the much smaller subset of those that actually support DS automation, so scanning and automatic updates. And there's only 8 of them now. If you look at, if you count the list there, I list only 7 of them because the 8th ccTLD, we're still trying to confirm whether they actually do DS automation. So we'll update that later. But there are a few other ccTLDs that we are aware about that are definitely looking at doing this. So Chile.cl is one of them that I know about. What about support in DNS software implementation? So most of the major open source ones at least already support the publication of CDS and CDNS key records, often automatically. And furthermore, some of them go an additional step. So they do what's called probing the DS set in the parent so that they know when to clean up old keys from the DNS key apex set when the DS record in the parent has been updated. So I think not DNS and ISC bind both do the latter additional function. As far as the commercial DNS providers go, the situation is not so good. I think there's only a handful of them, big ones like Cloudflare and DNS Simple, that actually do it. I recently took a look at a variety of other DNS providers that my company uses, like let's see, NS1, Amazon Route 53, Google Cloud DNS, and none of them actually support this today, although we are in discussions with them, and at least a few of them have it now on their roadmap. So hopefully progress will be made there. I'll switch gears a bit and talk about multi-signer DNSSEC. So this was a specification I helped develop a number of years ago, and it defines a mechanism that allows distinct DNS providers to cooperatively serve the same zone, but each provider signs the zone data with their own keys. So there's a long form presentation that I did about this protocol at OARC 30. That was in 2019. Incidentally, that was the last time I think OARC was in this corner of the world. That was in Bangkok. So you can read the details there, but let's move on to the next slide. And there's a diagram here where I've sketched out the scheme. I'm not going to dissect in detail. I'll just mention some key high-level features. So here we have 2 providers, A and B, that are serving the same zone. What they have to do is cross-import their public key associated with the key that signs the zone. And the parent zone's DS record then has to have entries corresponding to the hash of each of the providers' key signing key or CSK or secure entry point key, etc. And once you have this configuration, Bootstrap, this multi-signer operation will work. Next slide, please. So obviously tools are being developed to make the process of deploying multi-signer easier, but one very interesting aspect of this protocol is that it can readily be used to non-disruptively transfer a zone from one provider to another provider. And by non-disruptive, I mean there is no loss of resolution and no loss of validation, so nothing breaks even momentarily. And this can be achieved by deploying a transitional state of a multi-signer configuration across both the old and new provider, and at a later time, modulo TTLs and so on, detaching the old provider that's going away. So a lot of details of this are spelled out in another RSC draft that is making its way through the IETF. I won't bore you with the details. You can look them up yourself, but there's a link to the protocol spec there. All right, so sometimes we often get this question. So why do we need to have all this complex configuration machinery to solve this problem? Isn't it just easier to remove DNSSEC temporarily and go unsigned for a bit while you move to the next provider? And my answer is no. I mean, it's easier, yes, but there's a number of very compelling reasons you don't want to do this. So apart from the very obvious reason that you have downgraded the security of your zone and you have opened up a window of vulnerability where attackers can now spoof your domain names, that one is obvious, right? But if you think about applications that are protected by DANE, which is essentially, I will go into this now. There's a link to a tutorial at the bottom that describes it in detail, but essentially applications using the DNSSEC as a PKI, those applications will break and experience outages. And also it will prevent some organizations that don't want to degrade their security from moving to another provider. So that creates a vendor lock-in situation, which is also no good. And lastly, the point I want to make is if going insecure is a normal mode of operation for DNSSEC, in my opinion, it will never be taken seriously as a security protocol, and that is not something that we want. So we want multi-signer to be widely supported across DNS implementations, and let's take a look at that. This first table shows the state of support for the multi-signer API features across a set of open source DNS implementations, and as you can see, the situation looks very good. So the three that I've listed here, Bind, .dns, and PowerDNS, they have an almost complete set of support for it, mostly through the use of dynamic update. However, PowerDNS in addition support a REST API interface for these functions. And this one shows the state of support across a set of commercial managed DNS providers. Again, as you might suspect, the situation is not quite as good, but it's not terrible either. So progress is being made. And we're getting there. So some features are missing, and I think NS1 and Cloudflare are planning to close the gap there, and Neustar is also working on their implementation. There are several other commercial DNS providers who I won't name yet, who I know are working on this because they haven't publicly said anything. So there's work going on. I just want to also very quickly plug something here. Johan Stenström, again, and colleagues at .se have developed a very nice piece of software called the multi-signer controller, or MUSIC, that essentially manages the configuration of multiple DNSSEC signers and also handles the details of seamlessly transferring a sign zone from one provider to the next. There's a link to a more detailed ICANN presentation on the topic where you can read details and links to the code. So I encourage folks that are interested to look into that. What can folks do to help us with this effort? So if you're a DNS software implementer and operator, please support DS automation mechanisms and multi-signer DNSSEC. For DNS operators specifically, there is a separate issue. The fact that third-party DNS operators presently have no defined role in the ICANN registration ecosystem means that it poses challenges for them to be integrated nicely in DNSSEC automation schemes. It would be very nice if we could rectify that situation somehow and realize a formal role for them in the ecosystem. So if you're interested in tackling that effort and dealing with the ICANN policy-making machinery to make that happen, please get in touch with me. So I know Steve Crocker has a lot of ideas about how to get that process started. And zone owners, please ask your vendors, registries, and registrars also to support DS automation and multi-signer DNSSEC. There is some additional DNS protocol development work that needs to happen at the edges that I and a number of colleagues are still working on. I don't have time to go into those today, but if you're interested, please talk to me and I can hook you into those efforts. So that's it. So with that, I'll stop for questions and comments.
Thank you, Shumon. So please don't forget to rate Shumon's talk in the channel, and we are now open for questions.
Hi, David Lawrence, Salesforce. And so specifically on the issue of operators in the RRR model, I had actually been starting to pursue that back when I was at Akamai many years ago,
right?
Because it was identified as an issue there. And then as I moved around, I kind of lost track of the issue. You mentioned that Steve has ideas of how to get it started. So there isn't any, like, what's the status of trying to make that happen with ICANN right now?
Yeah, that's a good question. I don't know. I know I don't go to many ICANN meetings, so I can't tell you the details. I would encourage you to get in touch with Steve Crocker. So
Right.
he has broached this subject several times. So I think the idea is to start a stakeholders group for DNS operators.
Okay.
I don't know exactly what movement has actually happened yet, right? I think part of the problem is we have to get these third-party DNS operators to actually show up at ICANN
Oh, I know.
and push the case. So I think there's a gap here that we need to close.
Well, part of the gap was just understanding what the procedure was, because I gave a presentation in Johannesburg addressing specifically the lack of a defined role for operators and how that was really important for DNSSEC. So
okay, so can I ask you what happened with the Akamai effort when you were?
well, that was essentially, like I mentioned, several people said it's a good idea, but it was really unclear from the ICANN side what procedure would even be started to make that happen. And so at that point, I was kind of handing it off to, the ICANN suits, the non-engineering people who could do the policy part of saying, oh yeah, so, we need to work on this, but it lost traction because shrug, right? It just was not clear what policy would be used to, to kind of reconsider what that model would mean to recognize the real world existence of third-party operators.
Okay, yeah, got it. Thank you.
Ed Lewis, I work for ICANN. I'm in no position to answer what David is talking about. That's why I'm shy about where I live right now. Actually, I want to talk about slide 6.
Okay.
A little more concrete.
Can we go back to slide 6?
I want to challenge what's on slide 6. In a sense, I'd like to strengthen and improve the effort. When it comes to this particular issue, and I made this comment at the IETF a few months ago.
Yeah.
I know scanning is inelegant.
Yes.
And it's ugly, right? Polling is great. Event-driven systems are great. But there's no real empirical evidence that the scanning is actually failing anyone that's done this. And I would say, I would ride that horse until it has a problem. So before I get too excited, the reason why I'm saying this is that polling would add more work for the operator, more complexity. They have to stand up a server to do the specific thing. So it's a new thing for an operator to put in there. So as much as in the theory, we think that's a much more elegant, efficient way. Everything you said there is true.
Mm-hmm.
It may not play out as the best way to go forward because for pragmatic reasons, scanning actually is the way we normally go about life anyway. So this is kind of just this particular topic, I would say, let's not be so strong about thinking this is the right way to go, but let's get some more evidence before we think scanning will break. Because I do scanning some things and it does go pretty far. It's simple, but I'll just leave it at that. That as a thought.
Yeah, sure. I agree. At the current time, there's no empirical evidence that it doesn't work, right? So at the scale at which it's happening, CCTLDs are able to do it, right? So the question is, there's an open question is, as it really scales up, will it work? And I don't know the answer to that question. I do know that it is not as elegant as an explicit notification system. It's wasteful of resources, it's time consuming and laborious, and we should have a more efficient way to do this, right? So I'm not saying that you should not do this, right? Maybe that's the easiest option today.
I would just maybe strengthen the message of the slide either with numbers eventually. If it comes off here saying we want to poll, not scan. To go there.
I think you mean notify by poll, right? Notify, not.
Yeah, notifying. Poll,
Yeah.
So I would just work on strengthening some of the work going into this. And this is maybe a general comment because I've also had people flinch when I say automation is good. Because automation can also be very bad if it goes wrong. This is a great way to go, but we have to make sure we go do it in the appropriate and just the right way to go forward. So it's.
Yep. Okay. Point taken. Thank you, Ed.
So this is the guy who hates scanning. Let me just say that, yes, scanning works. So the question is not whether it works or not. The question is whether we can do something better. So I essentially agree with that.
Right.
That said, the generalized notification stuff is not only about sending notifications to the parent for CDS or CSync records. It's also about sending notifications sideways to another signer in a multi-signer setup.
Yep.
And in that case, we simply have no other solution.
Yep.
So in the parent case, scanners work. In the multi-signer case, there is no alternative to generalized notification. So we sort of need this mechanism regardless. But that's just in response to Ed.
Yeah, so exactly. So very good point. So the reason I didn't mention the multi-signer case is this was when I was talking about CDS, CDNS key, but that's a very good observation. I probably should have mentioned it later. Yeah, thank you.
The reason I came here was not for that, however. The reason is that you mentioned two use cases for multi-signer. One being that you want to have independent outsourced signers to get more redundancy and everything good.
Yeah.
And the second case you used was the transitioning without going unsigned,
right?
Both of which are nice. Working for a registry that recently had a rather bad incident in their DNSSEC signing stuff where two HSMs went to the dark side at the same time. I'm wondering if we should add a third use case to this set of use cases for the multi-signer stuff, where we don't outsource the signing. We have in-house signing, but we want to have two completely independent signer infrastructures. And in our case, in the Swedish case, they were sort of independent, as in separate servers and separate HSMs, etc. But they shared and synchronized keys between the HSMs.
Yep.
If we want to have it really separate, they should have independent keys, and then suddenly we're doing multi-signer in-house.
Yep. Yeah, thank you for that potential third use case. I agree. I think that sounds like a very natural use of the multi-signer protocol. I think if my understanding is correct, and feel free to correct me if I'm wrong, in this HSM, when you have these redundant HSM configurations, essentially they are proprietary interfaces that don't work with other systems, right? So essentially, you have a situation where the same configuration and the same keys are synced across both boxes, right? So if you have multi-signer, you could extend that and have it across different providers, different HSMs, and still work, and you have that compartmentalization and isolation of signing operations, right? So you'd be resistant against those kind of failures.
I think we should be careful about saying multi-sign will solve every problem, but I think there's potential here.
Right.
And again, speaking about HSMs, every gTLD and many other places on the planet, they run HSMs today.
Yep.
They run multiple HSMs, and they believe them to be redundant and nice and not failing. I'm just saying that all of us, including Sweden, we solved the redundancy problem by having two identical HSMs, both at the same time with the same firmware and the same keys. And if they fail, in the Swedish case, they failed at the same time.
Yep.
So you would be in a nicer place if you had two HSMs from different vendors with different firmware and different keys. That would be a more independent design.
Yeah.
But the HSMs don't support that. All of them support importing keys, but they don't necessarily support exporting keys.
Right.
So then that's where the multi-signer stuff would come in.
Yeah, there's some development work. And just to be clear, I wasn't claiming multi-signer would solve all problems. It would solve certain classes of problems like the one that you mentioned, right? Okay, thank you.
Yes. Yeah, I see there are more people that have questions, so I propose to take it to the workshop channel and discuss them further there.
Yeah.
Thank you, Shumon.
Okay, thank you, folks.